Hi, so for today we're going to talk about differential calculus, and more specifically we're going to talk about quotient rule. So we have discussed product rule and the basics of derivatives on the previous videos, and we are going to continue our discussion with this. So for the quotient rule, we have the following formulas here. Okay, of which if we have a function that is in terms of the numerator and the denominator, and we are going to differentiate it such as this function, for example, y equals 1 all over x. So we know that this is a quotient function, meaning it has a denominator. So if we see this function and we wish to get the derivative of this function, so we have to use the following formula. Suppose that we have u all over v, k prime, and that would be equal to v derivative of u, or the numerator, minus u derivative of the denominator, dv, all over v squared. Or we have a more common mnemonics in trying to understand rather than memorizing this formula. Okay, we have the mnemonics that we have if we wish to get the derivative of a quotient function, u all over v. So we have low multiplied by d high. What does that mean? Low here is the denominator and high here is the numerator. So we have low, okay? So we have low multiplied by derivative of high, which is the derivative of the numerator u, minus high, that means the numerator, multiplied by the low, the derivative of the denominator, that is the low, all over low squared. So low d high minus high d low all over low squared. It's much more easier to actually remember rather than v du minus u dv all over v squared. So you might forget this formula rather than memorizing the mnemonics that we have low d high minus high d low all over low squared. Okay? So again, we're going to apply this. So in order for us to further understand what we are trying to say here, let us solve some problems. So for example, we have y equals 1 all over x. So we know that 1 is our high because that's the numerator and x is our low. So let's apply. So if we have y prime, we have low derivative of high multiplied by the derivative of high minus high multiplied by the derivative of low, d low, all over low squared. So how do we do that? We first copy the low. What is the low? That is x. Okay, that's the denominator. Multiplied by the derivative of high. So you're going to get the derivative of high. That is 1 prime, signifying that derivative, 1 prime. Minus, we have high. Copy the numerator. So we have 1 multiplied by the derivative of the low, which is x prime, all over low squared. So we simply square the denominator. So we have x squared. So that's it. So if you're going to get the derivative of the function, so we have y prime. So we have x multiplied by the derivative of 1. The derivative of constant is 0. Minus we have 1. And we have the derivative of x. So we have to get the derivative of x, that is 1. Okay? With respect to x. All over x squared. So we can see, as we can see, x times 0 would be 0. So this whole term here would be 0. Leaving us with 1 times 1, that is 1. We multiplied by the negative, so we have negative 1 all over x squared. So hence, the derivative of 1 all over x squared would be negative 1 all over x squared. So that's how simple it is to use the quotient rule using the mnemonics formula low d high minus high d low all over low squared. Okay, so that is simply the derivative of y equals 1 all over x. Okay, so that's how you get the derivative. For number 2, let's try. We have y equals 2 all over x. Then we are going to get the y prime of that. So applying the formula again, we have low d high minus high d low. So we have low derivative of high minus high derivative of low all over low squared. Okay, so that's how we try to get the derivative of that. So we have y prime, we have the low, which is x, the denominator, and then the derivative of high, 2 prime, minus we have high, 2, that's the numerator, multiplied by the derivative of the low, which is x prime, all over x squared. Okay, we have to square whatever is the denominator. So getting the derivative, we have x times the derivative of 2 is 0, minus we have 2 times derivative of x is 1 with respect to x, all over x squared. So this would be x times 0 again. That whole term, or that whole term in the numerator will become 0. So we have leaving us with 2 times 1, which is 2, with the negative 1 here, negative sign. So negative 2 all over x squared. So that would be the result when we get the derivative of 2 all over x. Okay? So that's how we try to get the derivative of that. Okay, for number 3, let's try to solve another problem. We have y equals x plus 1 over x minus 1. So this is still a quotient rule because this function has a numerator and a denominator. So we have to get the y prime of this function. So again, we have low d high minus high d low. Minus high d low. The word d there, or the letter d there, stands for the derivative all over low squared. So let's try. What is the low? The numerator, or the denominator rather, is x minus 1. So we have x minus 1. Then the derivative of high is x plus 1 prime minus, we have high, x plus 1. That's the numerator. Multiplied by the derivative of low. That's x minus 1 all over low squared, which is x minus 1 squared. So let's try. We have x minus 1 multiplied by the derivative of x plus 1, that is 1. Then we have minus x plus 1 multiplied by the derivative of x minus 1, that is 1. All over, we have x minus 1 squared. So continuing our solution there, we can see here that the both of the x's will cancel. So yeah, let's have a space here. So we have y prime as x minus 1 times 1 is still x minus 1. Then we have x plus 1 times 1 is x plus 1. All over, we have, oops, let me just erase this again and try to write this. We have x minus 1 squared. Okay, so we have x minus 1 distributing the negative sign. Many students forget that. Okay, so we have negative x minus 1. So all over x minus 1 squared. So as you can see here, x minus x will cancel. So negative 1 minus 1 is negative 2 all over x minus 1 squared. So that will be the answer for this given problem. Negative 2 all over x minus 1 squared. Okay. Okay, for number 4, let us try. Take note that what I'm trying to give here are basics, no? Basic problem. So the bare purpose of this video is actually to remember and to memorize the mnemonic. Low d high minus high d low all over low squared. So let's try 3 all over x cubed. Let's try that. So we have y prime. What is the y prime? So we have y prime. We have low d high minus high d low. So we have low x cubed. Derivative of high, which is 3 prime, minus high, which is 3. And derivative of low, d low, would be x cubed prime. All over x cubed squared. Okay, so we're going to square the denominator. So we have x cubed, then find the derivative of 3 is 0, minus 3 times the derivative of x cubed would be 3x squared. All over, we have x cubed squared. So that is basically x cubed times x cubed. Okay, so that would be x raised to 6. So remember, whenever we try to raise, okay, a an exponential function x cubed with 2, we must multiply 3 and 2. And that gives us x raised to 6. However, if we have functions that are multiplied, for example, x squared multiplied by x cubed, we add, okay, the exponent. So we have x raised to 5. But in this case, it is raised, so we multiply. So we have now, as you can see, this one would be 0. So in our example, this becomes 0 because the numerator is always constant. Okay, so but that is not the case always. Okay, it depends on the given. So we have 3 times 3x squared, that's 9x squared, and we have a negative here. So that becomes negative 9x squared over x raised to 6. Okay, so we can simplify this. X squared, this would become x raised to 4. So that would be negative 9 all over x raised to 4. That would be our answer for this specific problem. Okay, so very basic, because what I'm trying to give you is the basics of the quotient rule. And in the previous or in the next discussion, the next video, I'll be presenting you a more complicated problem involving quotient rule. So for number 5, we have y equals, we have 2x plus 1 all over 2x minus 1. So again, applying the formula for quotient rule, low d high minus high d low. So low would be 2x minus 1 multiplied by the derivative of high, which is 2x plus 1 prime, minus high, that is 2x plus 1, multiplied by the derivative of low, low d high minus high d low. So that would be 2x minus 1 prime, all over, we do have 2x minus 1 squared. So you have 2x minus 1 squared. So let's try. That would be 2x minus 1 multiplied by the derivative of 2x plus 1 is 2. And then we have minus 2x plus 1. The derivative of 2x minus 1 is 2 also. So we have all over 2x minus 1 squared. Okay, so we try to simplify that by distributing 2 here, same as with the 2 here. And for this term, please don't forget the sign, the negative sign. So we have 2 times 2x, that's 4x minus 2. Then minus 2 times 2x is 4x, then 2 times 1 is 2. All over, we have 2x minus 1 squared. I'll be distributing the negative sign. So you have 4x minus 2 minus 4x minus 2. Okay, all over 2x minus 1 squared. So 4x minus 4x would be 0. Negative 2 minus 2 would be negative 4 all over 2x minus 1 squared. Again, the very purpose of this video is to familiarize ourselves with the mnemonics of the quotient rule and apply basic quotient rule in our problems. Okay, so for number 6, we try to find the derivative of, let's try to have, to prove that the derivative of tangent is the secant squared x. So let's try y equals tangent of x. Okay, so in the derivatives, we have already known that the derivative of tangent is secant squared of x. And here, we are going to prove why it is secant squared of x. So we know that tangent of x is simply equal to sine of x all over cosine of x by identity, of course. So what would be the y prime? Okay, so sine of x all over cosine of x is basically what? It's basically quotient function. So if we try to get the derivative of that upon applying the low d high minus high d low all over low squared or the quotient rule, so we have low cosine of x multiplied by the derivative of high minus high sine of x multiplied by the derivative of low cosine of x all over low squared. So we have to square the cosine of x in the denominator. So that would be the case, okay, upon applying the quotient rule. So we have cosine of x multiplied by the derivative of sine of x, that is still cosine of x, minus sine of x, and then what's the derivative of the cosine? That's negative sine of x. All over, we have cosine of x squared. Okay? So, let's try. We have y prime cosine of x times cosine of x. That becomes cosine squared of x. And we have sine of x times negative sine of x. That's negative sine squared of x. All over, we have cosine of x squared. So, distributing the negative sign, this becomes cosine squared of x plus sine squared of x. So, negative times negative would become positive. All over cosine of x squared. Okay, by Pythagorean identity, we know that sine squared of x plus cosine squared of x from your trigonometry, that is equal to 1. So, basically, this whole numerator equals 1. So, we have 1 all over cosine of x squared. Or that it would be 1 all over cosine squared of x. And again, by your trigonometry, we know that secant of x equals 1 all over cosine of x. So if we square secant of squared of x, that would be 1 all over cosine squared of x. So 1 all over cosine squared of x equals secant of squared of x. So that would become y prime 1 all over cosine squared of x by identity would now become secant squared of x. So that would be secant squared of x. And hence, we have proved that the derivative of tangent trigonometric function is secant squared of x. Okay, so let's try to have another example. Another example here. For number 7, we have y equals e raised to x minus 1 all over e raised to x plus 1. Okay, and then we are going to calculate its value, y prime. Okay, what is the y prime? At x equals 0. So, meaning, after getting the derivative, we substitute x equals 0. What would be the value? Okay, so this is a quotient rule. So we're going to differentiate e raised to x minus 1 all over e raised to x plus 1 prime. So that would be low d high, low, then differentiate high e raised to x minus 1 prime, minus high e raised to x minus 1 d low. So e raised to x plus 1 prime. All over, we have e raised to x plus 1 squared. So it's time to get the derivative to simplify this. So we have y prime. So we have e raised to x plus 1. Derivative of e raised to x minus 1 is simply e raised to x. Minus, we have e raised to x minus 1. And then the derivative of e raised to x plus 1 is simply e raised to x. That is all over e raised to x plus 1 squared. Now, we try to distribute this, e raised to x times e raised to x, and then e raised to x times 1. So we have e raised to x times e raised to x, that would become e raised to 2x. Okay? So, and then we have plus e raised to x minus, distribute this also. So we have e raised to 2x minus e raised to x. All over, we have e raised to x plus 1 squared. And of course, we try to distribute the negative sign here because of the minus. We have e raised to 2x plus e raised to x minus e raised to 2x plus e raised to x. So, e raised to 2x becomes negative while e raised to x becomes positive because of the negative sign. All over e raised to x plus 1 squared. So, as you can see, e raised to 2x minus e raised to 2x is 0. And then we have e raised to x plus e raised to x. That becomes e raised to 2 e raised to x. All over e raised to x plus 1 squared. Okay? And upon getting the derivative, the problem is asking what would be the value of the y prime at x equals 0. So this would be our y prime. But in order to get the problem, or to answer the problem, at x equals 0, we have to substitute at x equals to 0 to our y prime. So that we have 2 e raised to x, e raised to x plus 1 squared. So we have 2e raised to 0, and that would be e raised to 0 plus 1 squared. So any number raised to 0 would be 1. So we have 2 times 1 all over e raised to 0 is 1. That would be 1 plus 1 squared. That would be 2 times 1 is 2. 1 plus 1 is 2. Then squared. Okay, 2 squared, what that would become 4. So that would be 2 all over 4 or 1 half. So that would be our answer for this specific given problem. Okay. So down to our last number. Okay, for this video about the basics of quotient rule. So yeah, for number 8, we have to solve the derivative of 1 plus cosine of x all over sine of x. So as you can see, this is a quotient rule still. So we have to differentiate 1 plus cosine of x all over sine of x as a whole. So we have low sine of x, derivative of high, 1 plus cosine of x prime, minus high, that's 1 plus cosine of x. Then the derivative of low, sine of x prime, all over, we have sine of x squared. Okay, so let's try to get the derivative of that. That would be y prime. So we have sine of x, the derivative of 1 plus cosine of x would be negative sine of x. Okay, if you apply the sum rule in differentiation, you will get that. And then we have negative or minus 1 plus cosine of x. Then the derivative of sine is cosine of x. All over, we have sine of x squared. So yeah, if you try to do that, sine x times negative sine of x, that's negative sine squared of x. Then we try to distribute cosine of x here. So that would be cosine of x plus cosine squared of x. All over, we have sine of x squared. So what will happen? We have negative sine squared of x. Distribute the negative sign. So that would be negative cosine of x. Okay? And that would be negative cosine squared of x. All over, we have sine of x squared. Okay? So if I'm going to rewrite this such that this would be sine squared of x minus cosine squared of x minus cosine of x. I just commutatively, okay, rewritten the numerator as that. So we have sine of x squared. So if I'm going to get the, or factor out this negative sign, this is common. This negative sign is common to the both terms. Actually, to the third term. So I'm just going to get negative outside. So you have sine squared of x plus cosine squared of x. That becomes plus because if you try to distribute negative, that would become negative. Okay, so I've just factored out the negative one or the negative sign. So that would be minus cosine of x all over sine of x squared. So as you can see a while ago that we have an identity that whenever we have sine squared plus cosine squared x, this is simply equal to 1. Okay, so that would be y prime. We have negative of 1 minus cosine of x all over sine of x squared. Or simply, that would be negative 1 cosine of x all over sine of x squared. Okay? And furthermore, we can rewrite this as negative 1 minus cosine of x, okay, as the sine of x would be sine squared of x. That is the same with this. Okay, and by Pythagorean identity again, that the sine squared of x plus cosine squared of x equals 1. So if I'm going to put this cosine squared of x to the right side. So that becomes sine squared of x equals 1 minus cosine squared of x. Okay? So what happens is that this becomes what? So this becomes negative 1 minus cosine of x all over 1 minus cosine squared of x. Okay? And then, if I'm going to what? To, again, factor out the negative 1 here, or the negative sign here, we will be having the numerator as 1 plus cosine of x. And of course, if we are going to be really careful in seeing this, this can be the difference of, or the product of difference, the product of two squares. So we have 1 minus cosine squared x is simply equal to 1 plus cosine of x times 1 minus cosine of x. So if you FOIL that, you will be having this. So we have 1 plus cosine of x, then 1 minus cosine of x. As you can see, we can now cancel 1 plus cosine of x with 1 plus cosine of x, leaving the numerator as negative 1 all over we have 1 minus cosine of x. And that would be our final answer for this problem. And that's all about the quotient rule, and I hope you guys learned something new for differential calculus. And if you're new to my channel, please don't forget to subscribe on my channel. And for more videos like this in differential calculus and even in all of the engineering subjects, please don't forget to subscribe and check out my playlist on different subjects, okay, in engineering. So again, guys, thank you so much for listening. Again, this is Engineer Abat. See you again on the next video.